Welcome students. Today we are going to study about electric field. We have already studied in gravitation that a particle cannot itself interact with another particle kept at a distance. Suppose this is m1 and this is m2. This particle m1, this mass m1 cannot interact with this m2 by itself, which is kept at a distance. Suppose this distance is r. For interaction, this particle or object, it creates a gravitational field in the space around it, and this gravitational field exerts a force on this another particle which is placed in it, and similar things happen in case of electrostatics. Here suppose plus q charge is present. Now if we bring a test charge, suppose q0, and it is a very small positive charge, it is a test charge and it is a very small positive charge. And since this is a positive charge and this is also a positive charge, so this charge will repel this charge and will apply a repulsive force or electric force in this direction. So why this plus q charge is applying a force on this q0 charge or this test charge? Because it is applying a force on this q0 charge because this charge, it produces something in the space around it, and that is called as electric field, and this electric field exerts a force on this test charge. Similarly to in the gravitation, when the particle was here and it creates a gravitational field around it, and when we bring another mass in that gravitational field, it will experience a gravitational force. Similarly here, this charge, it creates electric field around it, and this charge, if we bring this charge in this field, then it will experience a force. So we can define electric field as a space or a region around a charge, or we can say source charge. Electric field around a charge, or we can say source charge, in which if we bring any test charge, then it will experience a electric force like this. Suppose here, this is the electric field due to this plus q charge, like this electric field. Like this, and if we bring this q0 charge in this region of the electric field here, then it will experience a force in this direction, that will be a repulsive force. Similarly, if we bring a q0 charge here, then we will also experience an electric force in this direction. That means we can say electric field is a region or a space around a source charge, where if we bring a test charge in this region, it will experience a force, electric force, and that force will be repulsive because here we are taking the plus q charge and test charge is also positive. And here, so we can say for the plus q charge, plus q point charge, electric field, it will be radially outward like this, and this lines with which we are representing the electric field is called as the lines of electric field or lines of electric force. And suppose if we take a minus q charge, then the electric field due to this charge, it will be radially inward, because if we bring a test charge here q0, a positive test charge here, then the force will be in this direction. Similarly, if you bring a test charge here, the force will be in this direction, the force will be in this direction, like this. That means the electric field will be radially inwards in case of minus charge. Here the electric field is radially inward. And here we can say that the electric field is moving away from the source charge, and here the electric field is moving towards the source charge, that is minus q. Now let's talk about the electric field intensity. Electric field intensity. And this q0 here, it is a very small positive charge, that means it does not create any electric field around it. Now let's talk about electric field intensity. We know that in case of gravitation, the gravitational field was given by F upon m. This is the force on the mass and this is the mass, test mass, at which we have to find the gravitational field. Now in case of electric field intensity, the electric field is given by the force on the test charge, and here mass will be replaced by the test charge Q naught, and this is the electric field. Now electric field intensity, and it is a vector quantity. Vector quantity. And this Q naught is a very small positive charge. That means sometimes it is also written in the book as limit Q tending to 0. That means this Q naught is a very small positive charge. And since this is a vector quantity, we can also apply principle of superposition here. Suppose here at this point, the electric field due to charge Q1 is E1, and similarly due to some other charge Q2, the electric field at the same point, let it be E2, and similarly due to some other charge Q3, the electric field at the same point, let it be E3. Then the net electric field at the same point here, it will be the vector sum of the electric fields, individual electric fields due to all the charges. That means it will be E1 plus E2 plus E3, so on. Now let's talk about the intensity of electric field due to point charge. Suppose here a plus Q charge is here, and we have to find electric field due to this point charge, intensity of the electric field due to this point charge. Then if we have to find electric field at any point due to a point charge, then what we'll have to do? We will bring a test charge Q naught and we will place here. Suppose a Q charge is here and we have to find electric field intensity at point P. Then what we will have to do? We will bring a test charge, a small positive charge, and place it at point P, and then we will find the electric field due to this Q charge at point P. And suppose the distance between Q and Q naught is R, and these two are the positive charges, so repulsive force will act in this direction, electric force, and that will be equal to K into Q naught upon R square. And we know that electric field, it is equal to intensity of electric field, it is equal to F upon Q naught. And from here we can also find its unit of electric field, that is equal to Newton per Coulomb. And here if we put the value of force, it will be equal to K into Q naught upon R square upon Q naught, and here this Q naught will get cancelled out and we will get K into Q upon R square, and this is the value of electric field due to a point charge at some other point P. K into Q upon R square, that is equal to 1 upon 4 pi epsilon naught into R square upon Q upon 4 pi epsilon naught into R square, and this is the value of electric field. Similarly, suppose if we have to find the electric field due to this Q at this point Q, then again we will bring a test charge Q naught and we will place it here, and suppose the distance between these two charges is R2, then the electric field due to this point charge Q at this point, suppose let it be point S, and if we bring a test charge Q naught here, then the electric field due to this charge Q at point S, it will be equal to KQ upon R2 square. Now what about the direction of the electric field? Here we have written this electric field in the vector form. That means the direction of electric field will be same as that of the electric force. That means the force is acting in this direction and the electric fields will also act in this direction. This is the direction of electric field. Suppose here minus Q charge was present and we bring a small positive test charge here Q naught, then it will attract the minus Q charge. Minus Q charge will attract this Q naught charge in this direction, electric force will be in this direction, and in this case the electric field will also act in the same direction as that of force, that is E. So we can write here the electric field, it acts along the direction of electric force. Now let's talk about and from here we can say that E is inversely proportional to the square of the distance between these two charges. And here if we draw the graph of E and R, it will be like this. As R tends to infinity, the value of electric field will be 0. And here this Q charge, always remember one point, that it is not affected due to its own field. That is, a charge will be affected by the field produced by the other charges, but it will not be affected by the field produced by itself. And now let's talk about the graph of E versus the distance between the two charges. Graph between E and X, and we know that E varies as E is inversely proportional to X square. Suppose there is a plus charge Q, and if we have to plot the electric field, it will be like this. And here we will take a sign convention that if electric field is in this direction, we will take the electric field as positive, and electric field is in this direction, then we will take the electric field as negative. Now here, this is the y-axis on which we have to plot the electric field, and this is x-axis, and this is minus x. Now here, there is a plus q charge, and we know that the electric field always acts away from the positive charge. That means electric field will be in this direction. That is, if you bring a test charge here q0, then electric field due to this plus q charge will be in this direction. And since electric field is in this direction, that means it will be positive. That means electric field will be on the upper side of the x-axis, on the above of the x-axis. And here we know that as x tends to infinity, electric field, it will be 0. That means here the electric field is 0. So the graph will be like this. And here, if we come to this side, here the electric field will be towards this direction, because if we bring a test charge here q0, it will repel this q0 in this direction. That means the electric field will also be in this direction. And here the electric field is negative. And we know that as x tends to infinity, electric field will be 0. That means at this point, electric field will be 0. So if we draw the graph, and here electric field is negative, that means electric field will be plotted below the x-axis, that is on this line. That means it will be like this, because as x tends to infinity, electric field is 0. And if we draw the graph of minus q here, it will be like this. This is minus q. Now, this is x, this is E. Now here, the electric field due to minus charge is always towards it. That means it will be in this direction, and here is electric field is negative. That means we will plot the electric field below the x-axis, that is on this line. And here, as x tends to infinity, we know that electric field is 0. And here is x tending to infinity, that means electric field will be 0 here, and the graph will be like this. Similarly here, on this side, the electric field will act towards the minus q charge. That means it will be in this direction. So here electric field will be positive, because we have taken this sign convention. Now here, as x tends to infinity, electric field will be 0. That means here the electric field will be 0, and the graph will be like this. Now, and this was due to the electric field due to the single charges. Now what will happen if two charges are placed at some distance? Suppose here the plus q charge present, and here is also a plus q charge present. Now, this is electric field and this is electric field. Now here, towards the left side of this plus q will have some effect, but it will not have any effect on this side of plus q, because these are both equal charges. If this charge was something like 2q plus 3q plus 4q, then it will have some effect on this side. But here, this charge is equal to this charge in magnitude. That means this charge will not have any effect to this side of plus q. And here, the electric field will be in this direction. That means E will be negative. That means it will be plotted on this axis. So here, electric field will be like this. Similarly here, to this side of plus q, this charge will not have any effect, because both are equal in magnitude. Similarly here, the electric field will be in this direction, it will be positive. It will be like this. Now, what about the middle here? Suppose we bring a test charge q naught here, then it will repel this q naught in this direction, and it will also repel this q naught in this direction, and these two charges are equal in magnitude. That means the electric field will also be equal in magnitude due to both of these two charges. That means electric field will get cancelled out and it will be equal to 0. Suppose due to this charge electric field is E1 and due to this charge electric field is E2, and E1 will be equal to E2, that will be equal to K into Q upon R square. Suppose this distance is R and this distance is also R. So these E1 and E2 are acting in opposite direction. That means the net electric field at this point will be 0, and here at this point the electric field will be due to this charge, that will be in this direction, that is it will be positive. And if it is positive, that means it will be plotted on this axis, So here the electric field will be like this, and here the electric field due to this charge will be in this direction. That means electric field will be negative. That means electric field will be plotted in this axis, so it will be like this. And here, since the electric field is 0 here, so it will cut like this. The graph will be like this. Now let's talk about what will happen if plus q charge is here and minus q charge is here. Suppose here a plus q charge is present and here a minus q charge is present. Now this is the minus charge, minus q charge. Now here the electric field due to plus q charge, it will be in this direction and it will be negative. That means it will be plotted on this axis and it will be like this. And here this is minus q charge, so the electric field here will be in this direction, that will be also negative. That means the electric field here it will be like this. It will be plotted on the axis below the x-axis. Now what about the middle? Now here the electric field will not be 0 at any point, because here if we talk about this point, if you bring a test charge here q naught, then this force, this q naught, due to this q naught, the electric field will be in this direction, and due to this minus u, it will be also in this direction. That means the net electric field will not be 0. If we talk about this point, then also suppose here q naught is present, then electric field due to plus q will be in this direction and due to minus q will also be in this direction. That means the electric field will not be 0 here. So here this is the plus charge q, so the electric field will be in this direction, that will be positive. So it will be like this. And here also due to this minus q charge, electric field will be in this direction, that means it will be positive. So it will be plotted on this. And here the electric field is not becoming 0 at any point in the middle. That means it will be like this. The graph will be like this. Now what will happen if we take both minus and minus q charges? Here minus q charge is present and here minus q charge is present. Now this is E and this is E. Now here, since this is a negative charge, so electric field will be towards the charge. That means here the electric field will be positive, and since electric field is positive, that means it will be plotted above the x-axis. And here due to this charge, the electric field is in this direction, that means the electric field will be negative. Now that means electric field is negative, that means it will be plotted below the x-axis, so it will be like this. Now what about the middle between these two charges? Suppose at this point if you bring a test charge q naught here, the electric field it will be in this direction due to this minus q, and due to this minus q the electric field will be in this direction, and due to this minus q the electric field will be in this direction, and both these two charges are equal. That means the electric field intensity due to this charge and this charge will be equal. That means the net electric field at this point will be equal to 0. So and here the electric field will be in this direction due to this minus q charge in this region. In this region the electric field it will be equal to, it will be negative. That means it will be plotted here. And if we talk about this reason, the electric field will be in this direction due to this minus q charge, and that will be positive, and that means it will be here like this, and it will cut the line here because here the electric field is becoming 0. Now let's do these two questions based on the concept of electric field. In the first question, it is given that 2-point charges having a charge of plus q and plus 4q are placed on x-axis at x equal to minus a and at x equal to plus a respectively, and we have to plot the variation of electric field on the y-axis. Suppose here plus q charge is present at x equal to minus a and plus 4q charge is present at x equal to a. Now here we have to represent the electric field. This is the y-axis and this is the x-axis. Now, in the previous case, we have just studied that when the charges were of the equal magnitude, this charge will not have that much effect to this side, but here this magnitude of this charge is very much in comparison to this charge. That means it will have effect on this side also, and electric field due to this positive charge to this side, it will be away from the charge like this. And due to this plus 4q charge, electric field also be in this direction, will also be in this direction, and we have taken a convention, sign convention, that if electric field is in this direction, it will be positive, and if electric field is in this direction, it will be negative. So here electric field is negative. That means it will be represented below the x-axis, and it will be like this. It will be like this. Now here if we talk about this side, here the electric field due to plus 4q charge will be in this direction, and due to this plus q charge, here this plus q charge will not have that much effect in comparison to the plus 4q, and suppose it is having an effect in this direction, it will also have the electric field in this direction away from the charge, and this direction we have taken as positive. So here the electric field will be represented above the x-axis. It will be like this. Now let's talk about the in between. What will happen in between the charges plus q and plus 4q? Here, suppose we take any point here. The electric field due to this plus 4q charge will be in this direction, and electric field due to this plus q charge will be in this direction. Now, at some point between plus q and plus 4q, electric field have to be 0, and we have to find the distance. Suppose the distance between plus q and plus 4q is L. We have used this method while finding the force, the net force, the point at which the net force on the charge is 0, in where we have studied the Coulomb's law. And here suppose at this point the net electric field is 0, and if net electric field is 0, that means suppose electric field due to plus q charge is E1 and due to plus 4q charge is E2, and if net electric field at this point is 0, that means E1 will be equal to E2, and for E1 we can write K into Q upon, let this distance from the point of plus q, that is equal to x, so it will be kq upon x square, that is equal to k into 4q. So this distance, it will be equal to L minus x, and when we have solved this equation, the value of x, it comes out to be L by 3. We have seen this in the previous lecture. So at a distance of x equal to L by 3, electric field will be 0. So if we talk about this region to the left of this point, here the electric field due to plus q charge will be in this direction, and here this direction is taken as positive, so the electric field will be like this. And if we talk about this region, here the electric field due to this plus 4q charge, it will be in this direction, and that will be negative, and here it will be like this. And now let's come to the second question. In the second question, it is given that the two charges of 10 coulomb and minus 10 microcoulomb, 10 microcoulomb and minus 10 microcoulomb are placed at the points A and B separated by a distance of 10 centimeter. Suppose this is point A and this is point B, and here the charge is 10 microcoulomb and here the charge is minus 10 microcoulomb, and this distance, it is equal to 10 centimeter. Now we have to find the electric field at a point P on the perpendicular bisector of AB. This is the length AB and this perpendicular bisector will be like this. That means is this distance, it will be equal to 5 centimeter, and this distance, it will also be equal to 5 centimeter. And this point is P. And this distance at a distance of 12 centimeter from its middle point, that is this distance is equal to 12 centimeter. And we have to find the electric field at this point P due to these two charges. Now suppose here if this is 12 centimeter, this is 5 centimeter, and this is the perpendicular bisector, so this angle will be 90. So from Pythagoras theorem, we will get this distance. This distance will be equal to 12 square plus 5 square, and it comes out to be 13 centimeter. Now, since this is a positive charge, so the electric field due to this positive charge will be in this direction. Will be in this direction. Electric field due to A. And this distance is also 13 centimeter. And this is a negative charge, so electric field due to this negative charge will be towards the charge, that is in this direction, EB. Now, here this angle is theta, and net electric field will be like this. Now, or we can say this angle is theta, so this angle will also be theta. And if this angle is also theta, because these two sides are equal, that means this is a case of isosceles triangle, and the angle opposite to the same sides, in case of opposite sides, angles opposite to the same side or equal sides are equal, that means this theta will be equal to this theta. If this is theta, this angle will also be theta. And if we take the components of EA and EB, it will be in this direction. In this direction, it will be EB cos theta. And if we take the component of EA, it will be EA cos theta. Now, and in this direction, it will have a component of EA sin theta. And in this direction, it will have a component of EB sin theta. Now, if we calculate the value of EB and EA, it will come out to be equal. Let's see here. This is EA. EA will be equal to K into Q upon R square, that is K into the value of Q is 10 into 10 raised to the power minus 6 upon the R square. This length is 13, that is 13 into 10 raised to the power minus 2. We will change it in meter upon R square. And this is the value of K is 9 into 10 raised to the power 9. And this value comes out to be 5.3 into 10 raised to the power 6 Newton per coulomb. And if we calculate the value of EB, it will also be equal to 5.3 into 10 raised to the power 6 Newton per coulomb, because the value of Q and R is same in case of AB also. So here EA sin theta and EB sin theta will be equal, that means it will get cancelled out, and here we will be only left with this component EA cos theta and EB cos theta. So the net electric field at point P, that will be equal to EA cos theta plus EB cos theta. And since we can take cos theta as common, so it will be EA plus EB cos theta. And since EA and EB are equal, so we can write it as 2 times EA cos theta. And from here we can get the value of cos theta. Cos theta will be equal to base upon hypotenuse. In this triangle, the base is 5 centimeter and hypotenuse is 13 centimeter. So it will be 5 upon 13. And if you put all the values here, that will be equal to 2 into 5.3 into 10 raised to the power 6 into 5 upon 13. And this value comes out to be 4.1 into 10 raised to the power 6 Newton per coulomb. This is the net electric field at point P due to the charges A and B. So this was all about electric field. Thank you.